Okay, hello, my name is Ayman. Today I will present you about my final year project, which is AI pothole monitoring system using Google Coral. Okay, let me share my screen first. Okay, first, I need to test the GPS sensor first. Okay, as you can see here, it works. Okay, this is GPS only. Okay, uh, I do not put into data yet. So before I explain about this one, let me tell you about how my final year project works. Okay, first, GPS and accelerometer sensor will detect the pothole, and GPS will reveal the location of the pothole with latitude and longitude, as you can see here. Then, after it detected, it will send into a Firebase. Example like this one. Notice that it have potholes, two potholes, and at the same time, we have a lot of object detection for object detection for AI on the road. Example, person, vehicle, or any obstacle like animals. So this one, data database, will fetch or have link with my own website that I created, which is here. Wait a minute. So if you notice here, I have two pothole here. So means that it's true that right now it linked with my database. As you can see here, this is my latitude, 3.16 and 101.7, which you can see just now my current place. Okay, and I have two pothole, just like how it described in database. I have two pothole that I detected. Okay, this one, if you can see here, this is my object detection. You have car, have person. You cannot see the picture here because it only lasted for 1 hour. If you want to see more picture, I already linked with Google Cloud, basically cloud integration. You can see here. You can see this is object detection for person. This is one for this is save the real time storage. I don't want to put this here picture here because it will become overload and it's not professional. So by putting into Google Cloud, since I have free trial Google Cloud, so I can use this for what we call unlimited, as long as it doesn't break my free credit limit. So that's why I put this all this one into this feature that had been detected by Google. Okay, so let me show you something. Okay, right now I want to test my final year project, whether it's work or not right now. Okay, first we go into Python script. Wait a minute. As you can see here, this is my what we call my code for detect pothole by using accelerometer sensor. For this one, I use ADXL345 to detect the accelerometer. Okay, this is my Firebase configuration to link with my database. And then I need to initialize Firebase. This is my model that I use to detect pothole. This one already have been filtered and already be resampling. Basically, this is perfect for pothole model. Okay. This is for GPS sensor. To initialize serial port for GPS, every serial port for GPS is different. For this one, I use TTY AM80. And this is the calculation for accelerometer sensor. This one to calculate x-axis, y-axis, and z-axis. Right? So how can I measure for y-axis? It's at the front of the vehicle, whether it's car, bicycle, and Z we all know Z is a gravity. So we all and 9.8 ms -2 convert into G, we got 1G, right? But this one, so for this formula, we assume that Y, your angle, since your angle cannot be calculated alone by accelerometer, we assume your angle is 0. So your angle is 0. You can see here, since your angle is 0, all roll and pitch angle become 0. That's how the formula works. So this one is get GPS data currently. And then after got the pothole detected, it will send the pothole location by using GPS and then send to real-time database. So this, okay, let me test first. Okay, let me show you. As you can see here, if I apply my accelerometer, this one here, I will apply the pressure into y-axis here. Z-axis is gravity, x-axis is left side. Okay. It's quite hard because the GPS sensor is quite low to receive the signal. Okay. Right now you saw the GPS coordinate detected in 3.168 and 101.0702. So this one is linked with with my interactive website. Let me show you. See, uh, right now, just now we have 2 pothole only, right? Right now we have 3. Okay, I will put my rental this. You see, there's one issue detect here. This is my GPS. This is my new pothole that I apply the pressure into my accelerometer sensor. So far, it works. 3.168 and 101.072. Same as this one. So we can conclude that my interactive website works very well. Right now. Okay. Where is my object detection? And also my image. Let's say I stay near, let's say I stay near into this pothole, which I already marked here. It will detect the object. If the object is near the pothole, it will give the signal from the telegram. Telegram will alert us that this is dangerous or hazardous potential, risk potential. So we go into another code. It's coral, coral, has a camera, also city, system. Okay, this is my code. First, I import all the library here, which relate with Google Cloud, Coral Accelerator, and also Firebase to store the data into real-time database. First, I need to initialize the Firebase admin SDK to link with database and my current GPS. And then this is what we need to initialize the Google Cloud Storage. So I can send my picture that I detect from camera into this Google Cloud. So I can save a lot of storage. Instead of put all the picture into real-time database, I can put into cloud storage, much better. So the second one, I need to initialize the GPS serial connection. This one is very important to enable the GPS. Okay, this one is we target the categories. I can detect 100 of objects, but this one I choose, which is the most important one to save the computational power. Okay, in this case, I use person, bicycle, car, motorcycle, bus, truck, bird, cat, dog, horse, sheep, cow, elephant. Notice that this is all obstacle on the road that I make a research. This one is last upload interval and upload interval. This is for object detection. To detect 5 seconds, and then it detect one picture. If let's say I do not have this one, it will detect every second of that, which means the feature that sent into Google Cloud Storage become unlimited, become heavy. So so this one I use for model. I use MobileNet V2 HTTP that apply. This one is very powerful because it can reach into 30 FPS, which is real-time detection, which is TensorFlow Lite with 30 FPS. For camera, I use 0, which is webcam camera that I use. Okay. If you notice that this is what first I need to convert frame into RGB and size for inference. This is for the sake of safe computational power. And then this one to detect the object. At the same time, the detect object will also detect the location, latitude and longitude of the object detection location. That's why it will show. It will show and send into Google Cloud. Okay, this one that I already explained to you just now, latitude and longitude for GPS coordinates. This is time detection. Like I said just now, timestamp minus last upload time equal to upload interval. Every second, it detect one picture. Instead of every second, it will detect every picture. This is to save the storage. This is to scale bounding box to the original image size. I can see this is very important. And then we need to draw bounding box and label to the frame. Instead of I take whole picture of PC, I just detect the object detection, like car, person, something like that. Okay. After that, we upload into Google Storage and save this all information, label, latitude, image URL, as I explained, to save the storage in real-time database, and also timestamp lastly. All this one we put into real-time database that I show you later on. This one to generate sign URL in real-time database. Okay, right now it's already complete. Okay, okay. This is the real one. The real one is this one. Spike tag 3. This is the that I will. If you notice that I add this one, why I need I add hover sign. Hover sign is to calculate the distance between pothole that I fetch into real-time database and my object detection. Since I fetch this one, the GPS into the vehicle. So basically, the vehicle GPS is the same as object detection, right? So since we have two latitude, so we can use Habersign formula. This is Habersign formula to calculate the distance. Okay, okay, this one last. this is send alert. Notice that this is a chat ID text to prepare the payload, and that says message to using Telegram API. If response is 200, basically successfully, then I receive alert sent to Telegram. If not, it will fail. This is another example that I do yesterday. Notice that I detect the object here. I have the object detected person at 3.167 and 3. And also 101.073. Basically, it works. But let me show you my AI works or not. Okay. This is my picture. You see, my picture detect. And it will give the location, and also it will send this one into Firebase and also Google Cloud Storage. Okay, let me cancel this one. What is the proof? The proof one is here. You can see it on. This is one person that I detect, which is myself yesterday. So what is the proof that I can link this one with Google Cloud? You see, let me refresh this first. You notice that this is 634, 630. Basically, just now I do that. So I open this one. We will see my feature here. Basically, it detects version 17347777237. So let me check that timestamp. Okay, this is what I detect just now. 3.167.491 and 101.703. Detect as version. Today, same 21 December, 6:33. Just now, I take that picture by using real-time detection. So my AI is work correctly right now. So how can I link this one with the distance of this one to alert the message that if this one is near the radius of 50 meter, it will give the signal to the Telegram. Okay, let me show you. Notice that this is what I got. 6:33. This is what I got. 6:33 p.m. So basically, right now I already got the alert from the Telegram that the pothole, the object is near the pothole, so it will give me the signal. Okay, so that's all from me. Thank you. If you have any question, feel free to ask me.